everyone. Here I am Vadal Sagar, and let us continue our discussion regarding the chapter number 10 in the standard number 10. We are now in a part number 10, so it's good for us. We are pass out from the 9 part of this present chapter. We talk about light also, we talk about reflections, we talk about refraction, refractive index, and now it is a time one of the great part of the chapter we are here, which is a image formations using lens. The lens is the transference system, so it is doing the refractions. So don't waste time and go ahead. That we already seen. There is a different type of lenses we have. This is the what are the terms that is associated. You should aware about these things. It is a principal point. The distance between this principal focus is f called. This is a c called. Parallel rays are meet always there, and other all the things. The image formations by the lenses. The lenses from the image by the refractions of light. So the image which is formed by the lens, their refraction is happen. How do the lenses form image? That are still question mark for us. Today I will introduce the how it form as the basics of the formations of image with the help of mirrors, which is also applicable in this our case. So there is not a worry about it is a completely new for us. What their nature and size and shape regarding the all other talks are similar to what we have seen. So before proceeding into the detail of the image formations by the lenses, we should know about the rule for the formations of image. So from where to where rays are refract, and if it is passes through that, so from where it will be refract. That are the terms of you should know. So today I'm not taking any kind of text, so you may found out this text in a textbooks. So here we are today, we are just understand what is exactly. If you want to write in the writing point of view, you can take over your textbook. First rules is when the parallel rays to the principal axis. Now you aware about what is parallel ray, what is principal axis, what is optical center, what is principal focus, focal length, center of curvature. If you have any kind of query regarding this talking, then you can go for the earlier discussions part, or otherwise you can comment, otherwise you can ask in any way in a section. Okay, so when parallel ray comes, it will refract. In earlier cases we have a mirror, so it is reflect in such a way, so it is passed through the f. Here refract in such a way, so it is passed through the focal length. If it is coming on this side, so it will reflect on the another side of the lens, so it will be the pass through the f. This is a case of convex, this is a case of concave. It is a converging, it is a diverging. So it is rays are coming, it is not bending in such a way, it is on converging because of due to the shapes of it, the spherical mirror. So it is a converge, oh sorry, diverge the right. But this diversion should be if it extendable to the f only. So you can't draw here, there, here, no. You have to take your scale and put in such a way, so your projections, your projection should be passed through the f1. So you have to put your scale in such a way already, so you can able to dot it. What is the mean of dotted line, what is the mean of solid line? Solid line say tells us about the actual rays goes, and dotted line is which is our imagination, our projections we are bringing back towards the refraction direction. So there is no actual light. Okay, solid line shows the directions of actual line. Okay, okay, this is the first rule. When it is passed parallel to the axis, it will reflect to the f. When comes passes through the f, it will be after refraction, it going to be parallel to the principal axis. This is a reverse rule for the first one. If it is passes through the f, then it will be bend in such a way. Yes, one of the best and very good for our next discussions. When any rays it is passed through the optical center, any ray it can be passed through the optical center, because in such a way it will be comes in picture, so it is passed through the optical center. So when rays pass through the optical center, there is no such kind of refraction will happen. You can able to see the light is very straight, there is no bending. So when light is passed through the optical center, there is a no bending, there is no refraction. Okay, go ahead. This is enough rules for this. Now we are start our main topic, image formations by the lens. In a first case, we have an option of the first object placed at the infinite distance. As I said, position of object at infinity. So at infinite we have a one object through which the rays are coming. So there is always a infinite, so it is all rays are always parallel to the principal axis. You can able to see set of rays, and they all are here. We have the image formation using particular the convex lens. So I am taking the convex lens. It is a converging, so it is a light are all are converge. This parallel rays bend to the f, this parallel bend to the f, this parallel ray bend to the f, this parallel ray bend to the f. Actually this is the original principal axis, this is bent to the f. They all are meet at the one point. At least two, or at least you should have it is meet to that point. So the meeting point will form the image. So your image is like just like a point. So as you can able to see, the position of image is on f, on the principal focus. Nature is the real because actually rays are meeting, so the real and inverted because the point highly diminished point size. Okay, now from the infinite distance you come to the nearer. Yes, before yes, sorry for that, but you have here we don't have much about this. Here is the basic thing. So how you are draw it is called ray diagram, and they are asking for the board examinations number of time. So kindly follow my step. It will be easy for you forever. You have to take your scale and take any line which is very finely straight line. Is it okay? At the middle of your notebook you have to draw one lens. The lens size should be 4 line above, 4 line below. So the 4 line to the 4 line, it means 8 line you are using. At the middle of this line is passing. So put your scale. This optical center is 0. Then from this optical center to 0, 1 2 3 4 of the scale, 3 you are marked to the f2, 6 you are marked at the 2f2. Now your reverse your scale in this direction 0, 3 you are marked as 3 centimeter, you are marked as f1, 3 6 centimeter you are marking as a 2f1. Okay, so total is a, this is 6 centimeter, this is 6 centimeter. You are completed your ray diagram in a 12 centimeter. Okay, from the infinite distance now we are, I am bringing beyond the 2f2. Okay, now you are putting your object which is a finite height and all about this is a symbolized as ab. As I said earlier, for the any kind of image formation you should take your first ray should be parallel to the principal axis. I am first ray parallel to the principal axis. As per the following the rules, it will be bent in such a way so it will be passed through the f. It goes. Okay, it goes because we need some extensions. Now we are using the second rule. When there any light which is passed through the optical center, it is a not a bending and it just goes. Automatically it will meet before 2f2. In this system, if you are putting your object beyond, then your object is nearer. We will see at the end of the conclusive type of one other side of the lens between the principal focus f and 2f. You can able to see there another side it will be form, and also between these two it is a real actually, and then it's also you can able to see it's upward is downward, so the inverted and smaller than the object also you can able to size also observed. Is it okay? Whenever the light is meet, you have to draw your arrow which is a symbolized as AB. So it is a prime B prime, it is inverted. Now you will come more closer on to F2 or to F1, any kind of it. You if you are taking the F1 system in this side, so F2 in this side, not a problem. Okay, your object is here, other all step you have to follow. Object is here, the first ray is parallel is goes, it will be bent such a way it will be passed through the F extension. You can able to extend up to this also. You can take your second ray. If you follow this very nicely, 0 3 6 3 6, then you're automatically your ray. And yes, the one more thing you have to take care, your pencil ink should be very thin. Okay, so it will be help you to exact formations of the image. So you can able to see that you're exactly on 2f, the on the other side of the lens at 2f it will be from on the other side, that you have to write real. You can never about this being because actual rays are meeting on this side, it is inverted also, upside and downside image form, same size. You can able to see there is exact same size image form. Okay, now the we are come more closer on between the two f2 in the next section on f1, and then next section we are on between o and f1. In this case we have a in between f1 and 2f1, so the f and f2f. Okay, now the as I said you, the first ray should be passed through the parallel. It will be bent in such a way, extension you have to provide. So then it will be second in optical center, you can able to meet it at the one point. So as you come closer, your images goes far. You can able to see in this case you are far, then image is close. If you come close, then your image is here to there, it will be goes, it means goes away. If you more close, then your image is on to f to goes far. So it is a, just like a hide and seek like structure. It means one thing is come closer, one thing is goes away from it. So this case is also very understandable, and it is a formations of image on the other side of the 2f2, beyond 2f2, real inverted. So one thing you can make a judgment. So the convex lenses are always from the real and inverted image, but not in all case. We will see somewhere it has not the real and inverted, and it is a highly magnifying also. Size of the image you can able to observe of object is this much, and size of the image is very high. Okay, now we are come more closer on f1. So that light is passed through the as per law, and as per law, oh, they are exactly parallel each other, so they are never meet. But we are thinking about the infinite parallel rays are goes and they are somewhere meet, so that much huge image will form. So this type of answer you have to mention. At on at the infinity, it will be maybe form on the other side. Real and inverted image will be formed, suppose it will form. Then magnified, highly magnified image, suppose these two rays are goes, and it will meet here. Then you have to make your object in image in this much size. Now make judgment of the same what I've discussed here. Okay, and now you have come more closer to f1 0 and f1, or optical center and f1, in between optical center and f1. First object you are taking, and then it is parallel, refract through the f. It is a not f2 is written for by mistake, it is a point actually here, so that will be passed through f. And second ray, it is a last. As you can able to see, there both are diverging each other. It means they never ever meet at any point. So the reflected ray, sorry, refracted ray, you have to extend backside, it's exactly parallel. You have to put your scale in this direction. You just extend up to some limit. This ray also you can able to extend, and they are meet. Oh, here there is no possibility to meet, there is no possibility to formations of image, but the virtually it has a possibility to form an image. So now you have to make a judgment on the same side, the beyond the 2f2 image will be formed, and this is a by extension, by forcefully of the by dotted line. So it is a virtual image, and it is a as the directions upside direction, so it is erect. And so you can able to judge, you can able to see the size of it, it's a highly magnified. Okay, now here we are replacing our convex lens by the help of the concave lens. Particular in this case, only the two case we have from the infinite distance, our rays are coming, they are diverging each other, so they are diverging in this direction, so it is passed through the f. It diverging in this direction, passed through the f. So the in the earlier cases in a convex lens, we in the infinite section the image is formed here. In this case the image is formed here, there is no problem. On the same side, the lens as the object, and then principal on the principal focus, it is a extension of light, so it is a virtual obviously, and it is erect, is highly diminished like a point size. And if it is at the finite distance, suppose at this height, then the first ray is parallel, it will be diverged in such a way, so it is passed through the f. Okay, and then optical center wala rules you can use, and then you can pass through this optical center. Oh, they are meeting at that, because the actual rays are this and this, they are never meet in these directions. So you have to extend one of its, this you can also extend, this is also extension, because same is this you can extend it. So they are the meet at the one point and the image will be formed. So in earlier, so in the concave lens, your image is formed between optical center and a focal point, and it is a by the extension, so it is virtual in the very clearly, it is erect also, and it is smaller than the object also. So we can make a judgment the concave lens is always form virtual and erect image. This is what we are discussed today about the image formation using the lenses. Thank you very much.